Hey everyone, and welcome back to PrepFusion. I'm Anish, and today we'll start our new chapter, that is the linear algebra. So this is the chapter 1 of engineering mathematics, and I hope you have watched the lecture 0 where I have explained the course curriculum for each branch. So there will be videos for each of the branches, so you watch your branch video, and there I have explained the course curriculum and what you need to study and what things you can skip in this engineering mathematics course. So here this linear algebra chapter is for everyone. Okay, it's for everyone. No, none of the branches have to skip this one. So you have to study everything from this first chapter, that is the linear algebra. So we'll start with linear algebra. So first, let's study the chapter name. Basically, what is the chapter name? Chapter name is linear algebra. So it is linear algebra. So let's understand the meaning of these two terms. What does linear means? Linear means if we plot it in a graph, it would look like a straight line, right? It would look like a straight line. So we have to understand what is a linear. What is linear? What is linear? I will explain what is linear. Okay, and also we have to understand what is algebra. Algebra basically means arithmetic operation with numbers or anything. So arithmetic operation, arithmetic operations. So basically what we'll do is we'll do arithmetic operations with linear equations. So like in the first lecture, what we'll study? We'll study linear equations, solutions of linear equations, then the vector interpretation of linear equation. So these two things you already know, in your during your childhood or class 10th, like you have been solving linear equations. Try to remember simultaneous linear equations. You are solving with method of substitution or some other method, right? Method of elimination, all those things. I hope you're recalling. So basically in this linear algebra chapter, that is what we do. We manipulate the linear equations and find the solutions for those things, x, y, z, if you remember. So let's first understand what is a linear equation. Just hold on a second, let me see everything is recording or not. Yes, this is recording, and yes, this is also recording. Fine. So what is a linear equation? A linear equation is an equation in which the highest power of the variable is always 1. Always 1. So highest power of all the variables in that equation will always be 1. What do I mean by that? So let's take a standard linear equation. Standard linear equation. It is ax plus by equals to c, where a, b, c are constants. So a, b, c are constants, and they belong to any real number. A, b, c belong to any real number and they are constants. Okay, and your x and y are variables. They are varying. Okay, they are varying, and a, b, c are constants. So here what do you see? What do you observe? The power of x and y are 1. Okay, the power of x and y are 1, and hence I should write this in like this, and x and y are variables. Okay, basically here either what we write in the line equation, we write y as a function of x. So y is a function of x, so we only vary x, and there is the relation between y and x, and then we plot it in the graph. Okay, but this is the standard form of linear equation. So as they have told, the highest power of the variable is always 1. As we can observe is this highest power is 1. So this satisfies the condition for being a linear equation. So that is the first condition. Now what it is telling us, just information based things, that it is also known as a 1 degree equation. It is a 1 degree equation because the power is 1. That is the reason. And the graph of the linear equation always forms a straight line. As I mentioned during the starting of the lecture, the graph of the linear equation will always form a straight line. This is the reason why it is named as linear. The simple reasoning for naming it as linear is the graph is straight line. Okay, so to understand this concept, we'll try to do a question. So identify whether the following equations are linear or not. So just by seeing the question, okay, just by seeing the options, you can say which equations are linear and which equations aren't, right? Like already have told you from like this condition that yeah, this one is linear, this one is linear, but these aren't, right? Because here the powers of my variables are not 1, it is half here and it is 2 here, so they do not satisfy the condition for being a linear equation. So these two are gone, okay, but let's plot it and understand more about it in depth. So if I plot it for the first equation, the first equation is x minus 3y equals to 6. So like how do you plot it? You just do one thing, like this is a linear equation, you just need 2 points. What are the simple points? One is the x axis intercept and another one is the y axis intercept. So the x axis intercept, x and y, okay. So the x axis intercept, what is the x axis intercept? Where it intercepts the x axis, basically in this x axis where my y is 0, so you just put y0. What do you get? If you put y0, you will get simply x equal to 6. So at x equal to 6, it intercepts my x axis. And what is the y axis intercept? It is the point where my x is 0. In this line my x is always 0, okay, my x is not varying here. So if I put x equal to 0, I get y equals to minus 2. So y will be somewhere around here. So I got the 2 points of a straight line. I can simply connect these two, okay. You can choose other points also. What you will observe is, you will observe that like they are satisfying the straight line only, okay. Now like how you could have done it, like you could have simply written it as a standard linear equation. How you write it? Y equals to 3 divided by 3 x by 3 minus 2. Okay, here you can directly see what is my x intercept and my y intercept. So this is this is 6 comma 0 and this is 0 comma minus 2. Okay, so these are my x y intercept. From here, like this is standard equation. So from here also you can directly plot it. These are 10-11 things, like 10-11 class things, so I'm not going too much into the details here. So another definition can be set for linear equation is that slope is always constant. So another definition, what I can say, the slope will always be constant. Slope will not vary. Like for a straight line, the slope is always constant. So this is also another condition for it to satisfy like linear equation. In this is basically for two variables, okay, two variables. Where I have two variables, basically x and y. For that, for three variables, things will change. We'll discuss about that. So yeah, this is one case. Now let's plot the b. How to plot the b? So why am I plotting you in front of it? So that you can understand like how to plot also, because sometimes in mathematics few things you have to plot in the graph, right? So all these things, everything is interrelated, so you have to understand how to plot also all these things. So not just studying the linear equation is enough, okay, you have to understand the holistic picture here, everything you have to understand. So let me just copy the axis. If someone haven't like done this plotting thing before, they can watch this, or if you have already, if you know how to plot this parabola or like this square root equation, you can simply skip it, okay, you can fast forward it, it depends on you. So let me take the second equation. So this is the second equation, under root y plus x. Now generally what we know is, we generally plot for the what, y equals to x square plus all those things, right? Parabola. So y equals to x square, that is a parabola. So what we can do is, we can convert this, we can take x up there and this will be x6 minus x whole square. Now we are not familiar with this, what we will do, we will just take minus 1 common in this like inside bracket. If you take that common, this will be x minus 6 whole square, because minus 1 whole square is 1 only. So yeah, that is what we do. This is x minus 6 whole square. Now we know the shape that we get is parabolic. Okay, we know the shape that we get is parabolic. So where is the y-intercept this time? So y-intercept is again when my x is 0. If I put x 0, it will be 36 plus 36. So my y-intercept is plus 36. And where is my x-axis intercept? So my x-axis intercept is at when y is 0. When is y is 0? Y is 0 when x is equals to 6. X is equal to 6. Okay, 6 comma 0, and this is 0 comma 36. Okay, now what else do we observe? We observe that this y will never go negative. How? Because this is a square term. At minimum it can go to 0. Okay, so minimum is up here. Okay, and it is always increasing. So this is like a parabola only. We know how the shape looks. So the shape will be like this. This will be the minima, because it is coming down from here. If I after this x, if I increase my x, okay, if I increase it to 1, it is minus 5 whole square, so it is 25. It is reducing. Then if I increase it to 2, it is minus 4 whole square, it is 16. So this is reducing here, and then after reaching 6, as I increase my x, it is increasing. So it will be like this. Okay, so yeah, this is the thing about this parabola. Now how can you cross verify it? So what you can do is, basically you can check the slope also. So if you want to cross verify a graph, right, if the graph you have drawn is correct or not, you can cross verify with the slope also. So if you write the slope y dash equals to 2x minus 6. So what you observe is, up until x less than equals to 6, my y dash is always negative. Y dash is negative, that is my slope is negative, which is again correct here, right? Before 6, my slope is always negative. What do you mean negative slope? Basically it is downward, right? The angle it is like, this is the negative slope, like the angle should be like this. If the slope is positive, it should be positive angle. Here it is negative angle with respect to the positive x-axis, so that's why my slope is negative. So here it is negative, but what we observe is slope is reducing. I mean reducing, going towards 0 as I increase my x, as my x is moving more towards 6. So x has reached here. So after this, what happens? If I increase my x, my slope becomes positive. So as we can observe, yes, it is become positive. So this graph is correct. Okay, that is how you can cross verify whatever you have drawn. Okay, so now let's move on to the third part. So, okay, this is x square minus 5 something. I think I did something wrong here. Okay, I think it should be replaced by this. Basically y equals to x square minus 5. No, this is fine, like this is same only, basically the parabola only, right? Basically the parabola only. So but here the xy intercepts are interchanged. Just xy intercepts are interchanged. So obviously these are also not linear. Like what I want to meant here is, the slope is obviously not constant. Also the what do you say, the graph is not a straight line, it is a curved line, so it is not linear. Hence from here also, from the graph also, we can say it is not a linear equation. So this will be same only. Okay, this will be same only, just the y and x intercept are interchanged. Just hold on a second. So what is the x intercept now? So x intercept is basically when my y is 0, which is what? I get 2x intercepts now, which is plus minus root 5. Because if you observe, if I make y 0, this is x square minus 5, and if I take under root, I will get two solutions, not one solution. Not only plus positive, not only positive under root 5, I will get negative under root 5 also. Because like if you do minus under root 5 whole square, it is plus 5. Also if you do plus 5 under root whole square, it is also plus 5. So x equals to plus minus under root 5. So I will get two intercepts. So basically the graph will look something like this. and it is a upward curve because this the coefficient of x square is plus. The coefficient of x square is plus. Okay, so like the coefficient of x and y both are positive. If the coefficient of x and y either one of them were negative, like either one of them were different, then it will be a downward curve. So all these are basic things. I'm not like trying to explain, go too much into the details here, just trying to explain the basics. Okay, so what is the this x intercept? We have two x intercepts. One is minus under root 5 comma 0 and another one is plus under root 5 and 0. Okay, and so now what is the y intercept now? So y, for y intercept, my x has to be 0. If I put x equals to 0, y equals to simply minus 5. So my y intercept is up here, which is equals to minus 5, which will be more down, but that's fine. Okay, but this time my minima is somewhere else. My minima is okay. I did it wrong. Actually, it should be in the symmetry. That's why I was doing like the minima will be in the y intercept only, because every point after this will be just greater than this, right? I mean greater than minus at like what is the minimum value of this? 0. It can't go lesser than 0. So obviously the minimum value of y will be minus 5, or you can simply do the calculus thing also. Okay, I plotted the graph wrong. That's how you can cross verify, okay, whether your graph were correct or wrong, whatever, right? Okay, so this is plus minus under root 5. The x intercepts and y intercept is minus 5 comma 0 comma minus 5. Okay, so these are y and x. Fine. So yeah, like as you can see from the graph itself, this is again not a linear graph. This is a curvature. So this is again not, does not satisfy the linearity. So we can plot another one, last one. Like we will do this a bit quick because don't want to waste much time. So the same thing, right? Y equals to 3x plus 1. This time the slope is 3, but a few things are different. Let me just copy this one. So 3x plus 3, again the y intercept. What is the y intercept? It is at x equals to 0, which is plus 1. So y intercept will be plus 1. It will shift up here. And what is the x intercept when y is 0? That is x equals to minus 1 by 3. So it will be something like this. Slope will be more like bigger. Okay, slope will be more here. So it is minus 1 by 3. Just hold on a second, let me reduce the size. Minus 1 by 3 comma 0, and it is 0 comma 1. Okay, so yeah, these are the things. So yeah, these are the plots. Here we can see the slope is constant, the line is a like a straight line, so it is a linear equation. So again the degrees are 1 here, so yeah, it again satisfies. So this is what I wanted to say. So next is we have to find the solutions. Find the solutions for the following equations. So I just gave you the graphs, right? Now you have to find the solutions for each of them. What do you mean by solutions? Basically solutions means the roots of the equation. Roots, like basically whichever point satisfy. Okay, whichever point satisfy. Okay, so what does solutions mean? Solutions mean points which satisfy the equations, given equations. Those are my solutions for this following set of equations. Okay, my solutions will change by if the equations are changed. Okay, these are the things. Now let's do it with the first method. So basically, what do we know? We know, like simple algebra we know, right? Algebra we know, so we can solve using the method of elimination. So let's solve the first this question with the simple method of elimination. Okay, so here let's solve this. So what do we do in method of elimination? Basically, we eliminate one of the variable, unknown variable. Like we first try to make the coefficients of this variable same, then we subtract with this, and then only another variable will be remained, and through that we will be able to find the solution for that particular variable. And I will put that variable solution in one of this equation, and I will find the solution for the another one. So let's just do it. So I will multiply this with 3 because to make the coefficients same here. So simply multiplying this with 3, this equation will become 3x minus 9y equals to 12, 3x plus y equals to 2. And now if I subtract these two, this is minus 10y equals to 10. So y equals to minus 1. Y equals to minus 1. Okay, so y is equals to minus 1. Now we'll put this value of y in any of these equations. Okay, in any of these equations. So this will be x minus 3 to minus y equals to 4. So x will be equals to 0. So sorry, x will be equals to 1. Okay, so here solution is my x equals to 1 and y equals to minus 1. So if I put this x equals to 1, then I get y equals to minus 1 again, which is correct. If I put this x equals to 1 here, 3 y equals to minus 1. So my solution, whatever I have solved, is correct only. But like, what is the interpretation of this? Like, what do you mean by this solution? Is there any visual interpretation of this? Yes, there is. So basically I was showing you how to plot the graph due to this reason, basically to plot the visual interpretation of this solution. So method 2 is solving using the graphs. Okay, so again, like let me just plot the axes. X and y. Okay, x and y. So now let's plot these two straight lines again. What is the what is this straight line? Its x intercept is 4 and its y intercept is y intercept is minus 4 by 3. So like the slope here, what we can see is slope is positive because the sign is same. If I shift this y equation here, the sign is same for them, the coefficient of x and y. So slope will be positive. Okay, and x intercept is y intercept is something negative, and x intercept is 4 only. So here it is 4 comma 0, y intercept is minus 4 by 3. No. 0 comma minus 4 by 3. So it is 0 comma, so this is 0. So yeah. So now let's plot the other graph. Here, what is the x intercept? X intercept is 2 by 3. So it is somewhere around here. And what is y intercept? Y intercept is 2. Okay, so it is somewhere around here. And what is the slope? This time it is slope is negative. Why? Because like, let me just write this anyways. So here if I write this in standard format, this will be y equals to x by 3 minus 4 by 3. Okay, and if I write this in standard format, this will be y equals to minus 3x plus 2. So here what do you see? The signs or the coefficients, the signs of the coefficients of x and y are same, hence the slope will be positive. Here the signs of coefficient of x and y are different, hence the slope will be negative, or you can directly calculate the slope whatever you wish to. So slope will be negative, hence it will be something like this. Okay. So its slope is -3, slope is 1/3, so it should be something like this. Okay, I'm not obviously not plotting the exact graph. Okay, please excuse me, I'm not plotting the exact graph if something like visually something error is there. So here what we see, like again let me mark the points. Y intercept is 2, and x intercept is 2/3. X intercept is 2/3. So yeah, these are the lines. Now what do you observe here? You observe there is some intersection. So this intersections, or like the point at which they meet, right, these two lines meet, is known as the solution of this particular equation, because this is the point at which both of these equations satisfy. This is the point where both of these lines satisfy the like they are at this particular line, right? So that is what do we mean by solution visually. So what is this point? This point is x equals to whatever we calculated over here, x equals to 1 and y equals to -1. Exactly we can see, right? It is somewhat lower in the y axis and somewhat positive in the x axis. So x equals to 1 and y equals to -1. So basically what does solution means? Solution means the intersection of lines in 2D. 2D means two unknown variables. Okay, so solution means everything is recording, right? Yeah, I just sometimes get scared if nothing is recording. Yeah, let me use some different color. Intersection of lines. Okay, basically this is for 2D. I have no sound is coming because someone is like using his mixer and noise is coming. Now for 3D, what will be the definition? But for 3D, what we can say? For 3D, what we can say is the intersection of planes. Intersection of planes. Okay, there will be exactly one point where all of the planes will meet. Okay, intersection of planes at a point. Okay, so yeah, these are the definitions. So for 4D I also don't even know, okay, like what is the definition. So for 3D I can say like it is the intersection of planes. There I think it will be something intersection of the volumes or something. Okay, so yeah, this is basically the definition of solution of linear equations. So let's solve for the second case. Let's solve for this case. So for this case, again, simply we will use the method of elimination. So if you use the method of elimination, what do we see? Method 1. So again, I will multiply by -2 on both sides. So -2 for the first equation, -2x. I'm just not writing that equation 1, 2, then multiply -2 on both sides. I'm not doing that because that will just waste time. Okay, so like I hope you can visually understand whatever I'm doing. So if I multiply -2 on both sides, I will get 6y equals to -8 and -2x plus 6y equals to -8. This is a previous equation. Now If I subtract this is plus, this is minus, and this is plus. If I subtract these two equations, what do I get? I get here 0, okay, because 2x minus 2x plus 2x 0, plus 6y minus 6y 0, and minus 8 plus 8 0. So 0 equals to 0. Okay, 0 is equals to 0. What does this mean? What does this mean? Is this true? 0 is equals to 0. 0, is this true? Yeah, this is always true. 0 is equals to always 0. That is the thing. So this is always true. Always true. Now what does this mean? This means whatever point I put over here, this will always satisfy. Let's take one point. Let's take x equals to 1. If I take x equals to 1, I put over here, what do I get? The value of y. If I put x equals to 1, this will go over that side, this will become plus 3. So y equals to minus 1. Y equals to minus 1. So from this first equation, I get y x. If I put x equals to 1, I get y equals to minus 1. Now let's put x equals to 1 again over here. If I put x equals to 1, this is minus 2. So this goes over there, this becomes minus 6. So y equals to minus 1. So again, this also satisfies the same thing. This also satisfies the same thing. So it satisfies for infinite values. Infinite values. So this also satisfies. Okay, let me draw this. I'll just take another example, and from there we'll understand. So again, let's take x equals to 4 this time. Let's take x equals to 4. If I take x equals to 4, this will be 0, y will be 0. So from the first equation, x equals to 4 and y will be 0. Okay, then if I take x equals to 4 here, this is minus 8. So again, y is 0. So again, this is satisfying the equation x equals to 4, y equals to 0. So like whichever point I take, it doesn't matter. It will always satisfy. It will always satisfy. What does this mean? This means they are always intersecting. Always intersecting. Here, only in a single point they intersected, where both of the equations satisfy. We get 0 equal to 0. That means this is always satisfying. Always true. 0 is always equals to 0. So that means this will always intersect. So let me plot this, and from there you will understand. So I will plot this and then come back, because I don't want to waste, or like, yeah, let's plot in front of the camera itself, because few people may get confused with this. So I just don't want to waste your time, because if you know already, you can fast forward, skip through it. Okay, so let me mark the axes. Sorry for the noise, actually. X, Y. Okay, now like what are what is this? X equals to minus 3y. My slope is, this time my slope is positive. Okay, and what is my x intercept? My x intercept is 4. X intercept is 4. What is my y intercept? Y intercept is when my x is 0, which is minus 4 by 3. So here my slope is positive. So my equation is something like this. Okay, now what about the second equation? Again, if I see what, like, my slope is again positive, because if I move this x over here, the signs of both x and y are same. Slope is positive. What is my y intercept? My y intercept is basically, make this 0, which is again 4 by 3. Same point only here. My y intercept same only, minus 4 by 3, not 4 by 3, minus 4 by 3. What is my x intercept? My x intercept is where my y is 0, which is again x equals to 4. X equal to 4. So they are same. The slope also, you can check, is same only. There it is just scaled by 2. Just scaled by 2. I hope you can observe this. So just scale by 2. So again, I shouldn't draw it exactly here. What I should do is, yeah, just in front of this. So here what is happening is that it basically, let me do one thing. Let me color these things, else you will not understand. Take this here. Let me color this here, else you will not be able to understand. Let me make this graph in the bottom. So did I do? Okay, no, this is the positive slope one, right? So sorry. So this will be positive only. 3x plus 1. Okay, and this is like this is the green this one and this, like both of them are same only, but just to visually distinguish between them. So here what do you see? They are intersecting at infinite points. So oh my god, the mixer got damaged or something. Something happened to the mixer. uh, they are intersecting at infinite points. What does this mean? This means that they have infinite solutions. They have infinite solutions. Okay, so basically they have infinite solutions. Whichever point you take, they will always satisfy. Both of these equations will always satisfy because one is derived from the other one itself, because this equation is basically the scaled version of this one. Okay, that's why. So we'll obviously understand all these things in later few lectures, but for now, yeah, that is the hint basically. Now let's take the third question. So this one is third question. So here again we use the method of elimination. So if you use the method of elimination, what do I need to do? I need to multiply -1 with this to make the coefficients of both of these equations same. So if I multiply -1 with this will be minus x plus 3y equals to -4, and this is minus x plus 3y equals to 2 itself. Now simply subtract this. Okay, and this is minus. So what does this become? This become minus x plus x 0, and this becomes plus 3y minus 3y 0. So 0 equals to -6. Is this ever true? Is this ever true? Is this ever possible that 0 will be equals to -6? Okay, whenever you see some of this like these type of things, right, when 0 is equal to -6 or 0 is equal to 1, either you have done some mistake in your steps, whatever mathematical steps, whatever algebraic operations you are doing, whatever arithmetic operations you are doing, either you have done some mistake, or like there doesn't any solution doesn't exist for them. Like two cases can happen. Okay, either you have done some mistake in your algebraic operations, or solution doesn't even exist for these two equations. Okay, so in our case, yeah, I have done everything correct only. Solutions doesn't exist over here. So here what can I say is, for this case, not never true, hence solutions doesn't exist. So what does it mean by graphically? Let's plot these two lines graphically, and from there we'll understand. So I will just pause the video. Okay, and then I will plot these two lines, and then we'll understand. Okay, so basically I have plotted these two lines. So here just a slight thing will be, the slope of them will be same for both of them. Here either like they are almost parallel. If they are not like if you are seeing that they are not parallel, then it's just my mistake, the drawing mistake. But these two lines are parallel with each other. Just hold on a second. These two lines are parallel with each other. Just let me improve the slope a bit. Okay, so these two lines are parallel with each other. Okay, these two lines are parallel. Okay, as these two lines are parallel, the slopes are same. Fine. In the previous case, also slope was same, but in previous case, the y-intercept and the x-intercept were also same for both of the equations. Here, the y and x intercepts are different. That's why they will never intersect, because slopes are same. Hence, they are parallel to each other. That is fine. But the y and x intercept are different. Hence, like they are, obviously in the previous case they were parallel, but the equations were same basically scaled, but here they are parallel and their x and y intercept are different, so they will never meet. These two lines will never intersect. Hence will not have any solution. No solution. Lines will never intersect, hence will not have any solution. Okay, so these are the important things to note here. So that's why this equation we got, because this doesn't satisfy, this is never true. And why is this never true? Because this can't be equal to this. Okay, obviously that's why this can never be equal to this. Basically at none of the points, none of the x and y points, they can meet. That is what basically this thing is telling us. Okay, so there is no solution here. So basically what we have studied, so I have taken three linear equations, and we have covered basically everything. Basically what can happen with the three linear equations, solution either can exist or solution cannot exist. Here no solution exists, so we're falling in this category. Okay, now if solution exists, there can be two subgroups. What can happen? I can have a unique solution. In the first case, what do you saw? We saw only one point that is satisfying these two equations, or only one point where these two lines are intersecting. But if I see in this case infinite number of solutions, if solution exists, fine, but here infinite number of points are satisfying. So I take any point, all of them points will be satisfying, so I will have infinite number of solutions. So basically three things can happen. Solution can exist, and if solution exists, I can have unique solution, or I can have infinite number of solutions, or what is the other thing? No solution exists. So basically what do we say this no solution exists? We say, like, what do we say to the equations? If the equations have no solutions, we say they are inconsistent set of equations. So they are let me write in different color. Inconsistent set of equations, because it is a set, right? They have to satisfy set of equations. Okay, they are basically inconsistent set of equations. So that is one thing. Now why do you call it? Because no solution exists. That's why you call it them inconsistent, because none of them points are satisfying these equations. Okay, this set of equations. Okay, so here when is this case? In the graph, just try to recall when they are parallel. Okay, they are parallel and their y and x intercept are different. So visually, if you want to remember, you can recall like this, that they are always parallel. Okay, and their x and y intercept are different. Now coming back to this unique solution, if we have unique solution, obviously there will be only a single solution. And like let's first let me tell what are these set of equations called. So if solution exists, then the set of equations are called consistent set of equations. So here they're called consistent set of equations. Okay, so yeah, why are they called? Because obviously solutions exist, that's why they're called consistent set of equations. So now in this subgroup, we have one unique solution and or infinite solutions. So in unique solution, obviously only one solution will exist. And how can you recall that? Basically they will intersect at a point. Okay, and for infinite number of solutions, they will always overlap each other. Graph will look something like this. Okay, and they will always be overlapping. This is parallel. If I can parallel, and this is like a okay, let me draw this with different color. And yeah, sorry, this is a point basically. Okay, and here in this case there is a overlap because all the points satisfy. Okay, so the solution is overlapping in nature. Here it is parallel and here it is point. So these are the things that you have to understand about linear equations. So for linear equations, only three cases can happen: either solution can exist, or infinite solution exist, or no solution exists. Basically for solution exist, unique solution, infinite solution, or no solutions. Okay, now let's shift our topic to matrix. So let's study about matrix a bit, because this matrix will help us to find the solutions. Okay, how, we'll see. So if this is x minus 3x y, sorry for that, how we can write this in matrix format? Basically what we can do is we can write this in two formats: in the row convention or the column convention. So generally people follow the column convention. Why, I will see you why I will say. So here how we can represent this in matrix format. So I can just take the coefficient 1 minus 3 3 1. I am just taking the coefficients of each of them. Now this is my variable matrix. Okay, and this is a column matrix. I will explain what is a column matrix in later lectures. So if you know, very good. If you don't know, don't worry, I will explain everything. Okay, so this is a column matrix. That's why this is known as the column convention to represent a set of linear equations. And what is this equals to? This is equals to simply 4,2. Now if you don't understand matrix multiplication, if you don't understand this, don't worry, just watch this, watch whatever I'm doing. I will explain this in the later slides, because it is not possible for me to explain everything in a single lecture. So I'm talking about diploma students if they don't understand, because normal who have done their 11th or 12th, they know what is matrix multiplication, but still I'm saying it to you guys. So like, is this whatever written is correct? So if how do we do matrix operation? So we do matrix operation row column. So basically this is the size of the matrix, right? Here I have, like, first we write row, then we write column. Okay, rows into column, 2 cross 2. Then this has 2 rows and 1 column. This has again 2 rows and 1 column. So matrix multiplication, if you don't understand, don't worry, I will explain later on. Okay, this is 2 2, and the number of columns of this and the number of rows of this should be same for us to get a proper matrix multiplication. Okay, so basically 1 times x, then minus 3 times y. So x minus 3y equals to what? The first row, right? First row is 4. So yeah, this is satisfying. Again 3 times x plus y equals to 2. Yeah, this is satisfying the second equation. So yeah, basically this is correct only. Our representation, matrix representation, is correct only. So you should write this in matrix representation, not format. Representation. Okay, no. Okay, so basically this is the column matrix. And how else can we represent? We can represent using the row matrix also. So if you want to represent using the row matrix, this matrix will remain same. X, no, this will also change. Okay, this will be transposed. This will be 3 minus 3 1, and this will be x comma y, and this is 4 comma 2. Now this also will be changed. This will be 4 comma 2. Basically the representation has changed from column to row representation. So what is the order of this? So order of this is like single row and two columns, 2 cross 2 and 1 cross 2. So here what we see, x times 1 then y times minus 3 equals to what, 4, the first column basically. This time I'm comparing the columns, and then x times 3 into y times 1, 3x plus y equals to 2. So this is satisfying. So this is the row convention, because this is a row matrix, because for row matrix we only have one row, and for column matrix we only have one column. So you can say column vector also they call it. So column vector, row vector. Okay, so row matrix, I will explain what is row matrix later on. Okay, don't worry, just giving you a flavor of this. Now what is the important point to note here? Why do we not use this? Why we only use this whenever you have solved any question, right? Everywhere we use this. Why? Because just the basic thing is, if you check this, this is taking in more space, more width of the paper. Okay, because like this is also taking more width. Okay, and basically and this is taking lesser width, right? So this will take lesser area than this overall. That's why we use this. Simple, that's the convention, that's why we use this. So we use this simple convention because it takes lesser space, you can observe. So use this simple because it takes lesser space, nothing fancy or something like there is a mathematical derivation or something. No, just it takes lesser space. So yeah, I have told you the matrix representation. So let's basically understand what is a matrix. Okay, let's understand the definition of a matrix. So what is a matrix? Like you already studied this in your like 11th 12th. So a matrix is a rectangular array or table of numbers, symbols or expressions arranged in rows and columns, which is used to represent a mathematical object or a property. Okay, so basically here what we are representing, we are representing linear equations, representing linear equations. Okay, we're representing numbers, obviously table of numbers, expressions with the help of arranged in rows and columns. So that is what my matrix is. So basically if A is a matrix, we can arrange like objects. Just remember, like objects here, these are the coefficients, they are like, these are the variables, they are like, these are my right hand side constants, they are alike with each other, right? Same. So we are arranging like objects, not different objects. Okay, that is very important point to note here. We are arranging like objects, like similar objects. Let me arranging similar objects, okay, to perform like multiple operations. Okay, my charger got just hold on a second, just hold on a second. The battery of my pen, yeah. Objects. Okay, so basically A will be equals to matrix. A is a matrix, and here we represent our matrix in terms of rows and columns. Okay, rows and columns, and it is arranged like this, array of elements, right? If you know this well and good. So here how many columns we have? 1 2 3 4 5 columns. So C1, C2, C3, and let me write this in a better manner. C1, C2, C3, C4. Okay, not 5, sorry, 4 columns, right? So we have 4 columns over here. So my column is 4, and how many rows I have? This is R1, R2, R3, R4, R5. Okay, so I have 5 rows. Okay, so yeah, it doesn't mean that they have to be equal or something, they can be not equal also. If they're not equal, then they are called rectangular matrices. If they're equal, they are called square matrices. So row is basically the horizontal part and column is basically the vertical part, right? Vertical thing. So I hope like this is the basic definition of matrix only. And few things I want to say about matrix, about the matrix size. So in this case, I've taken the example where I have 5 rows and 4 columns. So what is the matrix size or order of the matrix or total number of elements inside the matrix? So all of them mean the same thing. Matrix size, few points I want to tell. Matrix size or order of the matrix okay, or number of elements. Let me color this differently. Okay, so basically both of them, all of them has mean the same thing, and they have the same formula, that is rows into columns or R into C. So simply it is equals to what in our case 5 times 4, which is 20. So if you want to know how many elements are inside the matrix, okay, just do the row times column and you will get your answer. Okay, now another thing that I want to say is, like, this is already, I hope you know this, that if A is a square matrix, if A is a square matrix, then they have to satisfy one condition. My row has to be equals to C. Rows has to be equals to column. Basically, number of rows has to be equals to column. So let me write this in like total only. Number of rows equals to number of columns. And if I call my E matrix as a rectangular matrix, then what does it mean? It means that my number of columns are not equals to my number of rows. So then it is called a rectangular matrix, or also we can say it as a non-square matrix. So let me just color this differently. Non-square matrix. So in this case, my number of rows will not be equals to my number of columns. They will not be equal. Okay, so these are the few definitions. I will come to matrix also later on, but before that, let us do another question. So let us plot the vector interpretation of the following linear equations. So what do you mean by vector interpretation? I will explain by solving one of these equations. So they are only same equations, set of equations only, just will visually represent them differently. It is known as a vector representation. As I told you, right, this is known as a vector here, vector. Okay, so we'll see about that. So let's do the vector interpretation. So let me take the first equation. Like, we can represent our equations in multiple ways. It's not like I as I told you, right, told you here only, I can represent it in 2 ways. Okay, and previously also we represented it in some other way. So in this case also I can represent again this equation in 2 ways. How do we represent this? So basically what you can write is, you can write here the coefficient of x is 1 and here it is 3. So how to convert this in vector representation? Simply 1 comma 3. Okay, or you can write x 3x then plus the y vector, basically minus 3y plus y. minus 3y plus y equals to the like the coefficient vector or the constant vector on the right hand side, which is 4 comma 2. Okay, now it is 4 comma 2. Now can we simplify it further? So if I simplify it further, okay, I can take x common over here, I can take y common over here. So we can take common things from matrix if it is present in the all the elements of the matrix, only then we can take common. Okay, just to understand this, if it is present in all of the elements inside the matrix, only then we can take some variable out of that common. Okay, I hope you understand simple common thing. So if I take the common out, where will it be present? So one thing I want to say is, I can write my x over here, I can write my x over here. Tell me, where should I write my x? Should I write my x over here? I'm taking common, right? So what do you mean by common? So if I have, let's say, this equation, right, x square plus 3x, I can take x common like this, x plus 3, or I can take x common like this, x plus 3 into x. Both of them are same because they are 1D, they are 1D here, but here one is wrong, one representation is wrong and another one is correct. So please identify which one is the correct one and which one is the wrong one. So here, what is x? X is 1D only, so x is a single element only. So if x is a single element, so x has 1 cross 1, x has 1 cross 1. Okay, and whatever I told you, matrix multiplication is valid when the number of columns of this matrix, okay, the matrix before this and the number of rows of this matrix are same. Okay, then only matrix multiplication is valid. I will come to matrix multiplication obviously in the when I will discuss more about matrices, but just I hope you know this. Now in this case, is the matrix multiplication possible? So here obviously this is again 1 cross 1. Okay, the order of this 1 cross 1. Okay, and what is the order of this? Order of this is 2 cross 1. This is 2 cross 1, 2 cross 1 and 2 cross 1. So order of this is 2 cross 1. Okay, now here what do you observe? If this is 1 cross 1, okay, these are not satisfying, these are not satisfying because the number of columns of this is not equals to number of rows. So obviously I can't take my x in front, my x has to be behind this column vector. So that is the proper representation. Okay, so you have to keep these things in mind. So slowly, like, why am I explaining these basic things? Because IIT will play you with these basic things only. So if your basic concepts are not clear, then obviously they will play with you. Okay, they will give you some like a simple matrix problem, but they will just bring a bit of twist where formula won't work. So wherever formula doesn't work, then then it becomes difficult. This year also the paper was like this. Like everyone thought it was formula based, but when they tried to solve it, it was not. It was basically understanding the concept. That was more important. So that's why I'm telling you these basic things. So obviously this will be 1 3 plus again this y will be behind minus 3 1 2 cross 1, and obviously this is y. Okay, and equals to 4 comma 2. Okay, so this is my matrix basically. So now this is the vector interpretation. So this is known as the vector interpretation. Vector means like either you have one single column. We'll come to vector, all those things later on. Okay, don't worry. Vector representation. Okay, so basically now what we do, we plot this in the graph. How do we plot vectors in the graph? So let's say I'm in this x and y direction. Okay, x and y direction, and let's say these are what in the x direction. What is the unit vector in the x direction? I cap, and unit vector in the y direction, j cap. So this represents, just for understanding the vector representation, I'm doing this. Okay, this is nothing like this is a standard or something. I have made my own standard here. So this is I cap plus 3 j cap. Now can we plot this vector in this 2D plane? Can we plot it? Yes, we can. So 1 in the x direction, 1 I cap in the x direction, and 3 j cap 3 times in the y direction. So 1 and 1 2. Okay, let me mark the 1 a bit lower. 1 2 and 3. Okay, so this is 3 times in the y direction. Okay, so this is the first vector. Okay, the x vector basically. Now what is the y vector? Y vector is, just hold on a second, like someone has came at the door. Yeah, sorry for the interruption. Basically, like someone came at the door, so I have to again go and open the door. Himanshu wasn't in the room like that time. So yeah, let's start where were we? We're talking about the vector representation of this. So this I can write like 3 I cap. Let me write in different color. 3 I cap minus 3 I cap plus 1 j cap. Okay, minus 3 I cap plus 1 j cap. Now this also we can write. This one also we can represent 4 I cap plus 2 j cap. Now what is this telling us? Like with some combination of this vector and this vector, we will get this vector as my resultant. So let me plot it, then we'll understand it more better. So I've already plotted this first one. Okay, let's plot the second one. So if I plot the second one, okay, let me color this as the violet one. Okay, and then this one has the minus plus, so minus 3 in this negative direction and plus j cap. So this will be something like this, 1 2 3. So here somewhere around here I will lie, and plus 1 j cap, this. Okay, so this is minus 3 and plus plus j cap. So like this is this line. Now let's plot the third vector, 4 I cap plus 2 j cap. 4 I cap, 1 2 3 4 and 2, somewhere around here. Four I cap plus 2 j cap. Okay, so what we have to do, we have to find some linear combination of these two vectors. So that's why this is represented as linear equation. This isn't like the power of this is 1, some linear combination of x and y, so that I can get this resultant 4,2 vector. So is there a linear combination here? So what do you observe is, if I put, like if I take one of this vector, okay, and minus one of this vector, the opposite end of the vector, then I will satisfy this equation. So let's understand it graphically. So here, like if I put x equals to, let me take another color. If I put x equals to 1 and y equals to minus 1, I will satisfy my equation, right? So that is what we solved previously earlier. So let's see the vector representation of this. So basically I have to take negative of this, negative 1 times this. So obviously what happens in negative, I just change the direction of this. The direction is completely opposite of this one. So here the direction will be like this, because we can observe, right, we have to bring this one down, and this one, if I simply add these two, right, in some positive direction, my resultant will be somewhere here, which I don't want. I want to bring this one down. So obviously I have to either add the negative of this or add the negative of this. If I add the negative of this, then my resultant vector will be somewhere here, which is again I don't want. Hence I have to make the negative of this, and the resultant will lie somewhere around here. That's why I'm taking the negative of this y vector and not the x, like negative of this y vector, not the x one. That is why. Okay, so yeah, let me just put this here. Okay, and obviously my drawing isn't perfect here. So what will happen here is, if you just do like draw parallel lines, this is the simple parallelogram law and simple vector addition. So if you do this, you will get your resultant. So your resultant will be 4,2. So this is basically the vector representation of this linear equations. Just hold on a second, let me check everything is recording or not. Yeah, everything is recording, fine. So yeah, so that is what I was saying, that here only one combination of x and y can give me this resultant. So here it is unique solution. Slowly when we will see the infinite solution and no solution, there also we'll understand the difference between this and that. So unique solution. Okay, so let's do it for the second equation. So what is the second equation? Second equation is this, second set of equations is this. So let me copy this and paste it here. Okay, and then obviously 1 minus 2 x plus minus 3 6 5 equals to 4 minus 8. Okay, 4 minus 8. So now what next? So here again let me draw the vectors. So this is what this is, I minus 2j, this is minus 3i plus 6j, and this is 4i minus 8j. So I minus 2j, so single in the positive x direction, then negative 2 in the y direction. So this will be somewhere around here. Okay, then minus 3 plus 6j, so negative 3 in x direction, then positive 6 in y direction. So basically if you like, if you draw this perfectly, what you will see is these two are completely opposite of each other. Okay, basically they are representing the same things only, because the negative of this will be this, they're representing the same thing only. Okay, so what is my resultant vector? My resultant is 4 comma minus 8, which is 4 steps in the positive x, then minus 8, it will be somewhere around here. Okay, minus 8 will be very very down. Okay, so it will be, yeah, somewhere around here. Let me just do one thing, shift this one in the top. Okay, and just mark this x and y. 4 and minus 8 will be very very down actually. Okay, I won't be able to properly represent it, it will be more down, like this is not properly representing that. So this is 4 comma minus 8. Okay, 4 comma minus 8, this is minus 3 comma 6, and this is 1 comma minus 2. Now like these two, right, these two are representing the same thing, these two are representing the same thing. They are in the same equation of line, right, they are parallel to each other. Okay, so none of the combination here can satisfy. Sorry, okay, I made a mistake over it. Okay, sorry, this will be, okay, this was for the third case, this will be almost on this line itself. I'm really sorry, this would be on the almost on the line itself. That is what I was like, that is why I was getting confused here. Why is this looking like same? Like if we just check, right, so here x and y are related, like x equals to minus 2y in this y equals to minus 2x in this equation, right? So here this is also y equals to minus 2x. So yeah, apologies, my mistake basically. So this is 4 comma minus 8. Here what we see is these two are like this, doing the same thing only, and any combination will satisfy. If I take one of this and then again I take what or if I take minus 2 of this, and if I take 1 of this, is that correct? Yeah, if I take 2 of this, if I take minus 2 of this, if I take 2 of this, then it will satisfy, and it can satisfy infinitely many solutions, because I can take the length proportional to this, right? Any length I can take, and another one I can add, still I will be ending up in the same line itself. Okay, I won't be able to get in this combination because these two lines are in the same straight line, and the resultant is also in the same straight line, same vector. Okay, they're representing the same vector. So basically there are infinitely many solutions, because like as I told in the previous example also, like in the previous method also, that you can find infinitely many solutions from this. Okay, by solving this, you either take one of the values of x, and for that same value you will find y, and then again you will solve the second equation, and then also it will satisfy the same values. So yeah, here there are infinitely many solutions, infinitely many solutions. Okay, so now let's go for the third case where I had no solutions. So in the third case where I had no solutions, again let me copy this equation. Here the difference will be just one thing. Okay, I will tell you what is the difference. The resultant won't lie on the same equation, same of this line. Okay, this will be somewhere else, as I was drawing previously, as I was making the mistake over there. So resultant won't be in the same direction. Now direction of resultant will change now. Okay, so again let's use the matrix. So basically this first vector is 1 comma 1, so it will 1 comma minus 1, so it will lie somewhere around here. Okay, it will like square only. So yeah, then minus 3 comma 3, so minus 3 is here and 3 is positive, so here. Okay, this time also they are in opposite, right? They are in opposite direction, same only. But what is the difference this time? The difference is this line. This is not in the same direction anymore. Here my x was equals to what, like just representing like my x, like these two things, don't like get confused. Okay, I am just telling about these vector. Like this was negative of this was negative of this is a negative of this. Previously both of them, all of them were satisfying, right? All of them equations were satisfying. Okay, you take any of them, any combination of x and y, because here they are always satisfying. Like you take one of this, like this is the negative 2 of this, sorry, yeah, this times negative 2 is this times negative 2 is this times negative 2 is this. All of them are satisfying. Basically they are in the same line, but here these two are satisfying the same relation. Okay, these two vectors, I mean these two vectors are satisfying the same relation, but this isn't anymore, because this is negative, this is negative of this is negative of this, but this isn't negative of this. So where does this lie? This lies somewhere around here, 4 1 2 3 4 1 2. Okay, this lies somewhere around here, not in the same line, okay. Now with any of this combination, any like combination of these two, can we ever produce this one? Can we ever produce this vector, resultant vector? No solution, right? We can't. We take any solution, we take any like point, any values of x and y, we will never be able to find this resultant vector. Okay, we will never be able to get this resultant vector. So here this is minus 3 3 1 comma minus 1, this 4 comma 2. Okay, so we will never be able to get this. So here no solution exists. Okay, no combination of x and y satisfies. This equation. Okay, so yeah, this is the about the vector representation. So now let's summarize whatever we learned. So systems of linear equation. So if we have what, m number of linear equations, so here these are just written, just don't worry about the notation, these are just n number of linear equations. So I will write m is the number of linear equations. How many linear equations we have? Number of linear equations. Okay, so if m is the number of linear equations and n is the number of unknowns, like I have n unknowns. So there previously, how many, this was solving in 2D, so I had two unknowns, x and y. I have to find the value. So if I have m number of linear equations and n unknowns, then how will the solutions look? Obviously, so you know one thing, right? If we have two unknowns, you need two equations. If you have three unknowns, you need three equations to get a unique solution. I hope you already we have studied this since childhood. So m is the number of linear equations and n is the number of unknowns. Okay, so basically yeah, so now let's write the standard matrix format. So our equation in matrix format will look something like this, where x is the unknown. Okay, x is the unknown vector of the unknowns. A is the basically this matrix of the coefficients of the weightage, right? So these are the matrix of coefficients, and this is the unknown vector. Okay, and b is basically the right hand side vector, whatever is in the right hand side. So a system of equation is said to be consistent if it has at least one solution. Okay, if it has at least one solution, it is said to be consistent, as I told here, right? As I told in the previous case where I have bifurcated the three. Here it is said to be consistent if it at least have one solution. At least it can have infinite solution also. And a system of equation is said to be inconsistent if it has no solution. So if it has no solution, then we can say that like it is inconsistent. As I wrote over here, no solution, and it is inconsistent set of equation. Now I told you, right, for us to get a solution, the number of equations have to be equal to the number of unknowns, like number of yeah. So but even when number of equations are equal to number of unknowns, sometimes I'm getting a unique solution, sometimes I'm getting a infinite number of solutions, sometimes I'm getting no solution also. So it is not the only condition to satisfy to get a valid solution. Okay, that is one of the solution. Yeah, we have to have at least number of equations should be equal to number of unknowns to get a solution at least. But it may so happen that that isn't the only condition. If number of equation is equal to number of unknowns, as we saw in this case, in this case, then also it may so happen we are not able to find a solution. Then it is called a inconsistent set of set of equations. But so then how should we know that whether this set of equations will have a solution or not, or will have a unique solution, infinite solution, or no solution? How can we tell? Because that funda got over, right? That what we used to say, the number of equations should be equal to number of unknowns, then it will have a unique solution. That funda got over because I took the examples, same thing. So how to find? So basically, if I have matrix, so let me just take this matrix. Okay, ax plus b. Let me just write a 3 cross 3 matrix. So if I have this type of matrix, right? Let me just copy the previous case. Just copy this. That will be easier for us to do. If I just copy this now, let me put this in the equation format, ax plus b. Let me put this in the equation format. Here it was individually, now let me put this in the equation format. So let me just copy this. Just hold on a second. Just delete this, ax plus b, right? So what we can write is, this is ax plus b. Okay, so now from this particular, not this is x, sorry, this is not x plus b, this is x equals to b, sorry. So from this, can we tell anything? Can you say anything about the solution? Obviously these mean something, right? These mean something. Okay, these have some meaning. So what we'll do, we will find the rank of this. Okay, I can't even make a bracket, very bad thing. We'll just find the rank of this. Okay, rank. But sir, what is rank? Obviously we'll learn this, don't worry. This is the main thing about this chapter, rank. And through rank we'll find the nature of the solutions of the systems of equation. So we find rank, and rank will help us identify the nature of the solutions. So rank will help us identify the nature of solutions of the system of equations. Okay, so this is what a rank does. Basically, when there are more variables, basically like what you could have told me is why do you need to find rank? We can just simply solve that. We can simply solve and check for ourselves that whether the solution exists or not. We solve for the two unknowns case. Just try to solve for the three unknowns and three equations. You will see the steps become more rigorous and it becomes more difficult to find the values of x, y, and z. So that's why we solve it like this. There has to be a system with which the help of we can easily identify the nature of the solutions without much computational power. So basically we won't solve the values, we won't find the solutions, okay, but we can say about the nature of solutions with this rank. So there is some trade-off, right? With that consideration, with that method of elimination, we can directly find the solutions, okay, but here we won't find the solutions, but we can say about the nature of solutions, whether solutions exist or not, are they unique or not, are they infinite, are there no solutions. So three cases only, so we can tell about that with much lower computational power, with much lower time taking process. So that is the reason we do this. So that is basically what is written over here. When there are more variables and equations, it is hard to do calculation by hand or graphically. Graphical method, as I have told, it becomes more difficult to plot things graphically. It becomes more computationally expensive. Okay, so in this situation, the system of equation is converted into matrix form, and the rank is determined to find out the nature of solution. So we can write this system of equation in matrix form, and and the rank is helps us to determine the nature of solution. We'll do the rank, and from there we'll understand. Okay, so yeah, that is basically the first lecture, basically just to give you a brief of why we are studying linear algebra, why it is needed. Okay, you have to understand why do we need linear algebra, because mostly what will happen is in control systems, in anywhere, what we do is we try to our this nature, right? Everything in this nature, whatever is working in this nature, everything is non-linear in nature. We try to linearize that, we try to model that first, then we see that it is non-linear, we try to linearize it, then what do? We try to solve the equation. Okay, to solve this equation, linear algebra will help us do that. That is why we study this. Like basically we are engineers, right? We have to know, like we will obviously use this, we are using this, but we don't know that in state space equation we are using linear algebra. Okay, so everywhere we use linear algebra. In AI also linear algebra is used. In civil engineering, in everywhere linear algebra is getting used. We linearize everything, then we solve for this equation, and then we model the non-linear thing. So obviously we try to first understand the simple things, then we go to the difficult. Obviously you are at class 5, you won't study class 10 things. First you will study the class 5, then class 6, then class 7. Okay, so first study the simple things, then we go to the more difficult part. So that is the main thing, that is what I want to tell. So here we use linear algebra to study how to solve linear systems of equation, and linear systems of equation is to solve linear systems of equation is required everywhere. We have to solve Always, we are always doing this. The solutions of the linear system of equation depends on the concept of rank. We can use the concept of rank by converting the linear system of equations into a matrix, as I explained earlier. Okay, we obviously will study more about matrix, we study more about solutions. This all will get into your head. This first lecture is just to give you a brief introduction and intuition about the chapter linear algebra. To understand matrices better, we need to learn the fundamentals of determinants. Okay, so what is determinants now? So like if you have studied 11 12, you know what is determinants. If you haven't, I will explain in the next lecture. Okay, to understand matrices better and to understand the concept of rank, we have to learn the fundamentals of determinant. That is why we study determinants. So first we have to study determinants, then we will be able to study about rank, and then we will be able to solve linear equations. Okay, so the problem was this, but to like solve this problem, we have to study all this. That is why we study all this. Okay, so yeah, this is basically the end of this lecture. I hope you like this lecture, and like if you have any more doubts, you can post in the doubt section, okay, or in the Telegram group. And yeah, basically I will see you in the next lecture. Thank you for watching.